Okay, everybody, we did a couple of things today. One, we did a recap on our max min problems, which we did the day before, but I wanted to go back through and show how to do it on the calculator. Unfortunately, I can't let you use your phone on the test, so there has to be another way to do these problems with max and min. So, on the day before, we did the box problem, and the equation we got was y equals. I pushed y equals on my calculator, and then I'm going to clear that out, but I want y equals, and put the equation x variable, parentheses, 21 minus 2x, parentheses, 28 minus 2x, okay? And then I'm going to put my windows to make how big my graph is. I do know that when we talked about domain, hey Eric,
hey,
come on in, I'm recording, which is okay.
oh,
So I do know when I go to my domain, that's my x value, so for sure 0 to 12 will work. Now my volume, it's going to be a big box. So my volume on my Y max, I don't know, I'm going to go big. I haven't know the answer, but I'm going to go big. I'm going to go 2,000. It's a big box, okay? So then once I make my window, I've got my equation in. I should graph it, okay? All right, there it is. So I push graph, and I'm looking for my maximum. Now here's a button in blue. So listen, here's my button in blue. So I want calculate. So I go to blue. Second, calculate. Go to maximum. I'll look for the maximum. Enter. I need to tell the calculator where to look. It says left bound. So I'm looking right here. I want to put the cursor over here somewhere. I'm just telling the calculator where to look. Okay. Anywhere on the left-hand side of my maximum. Enter. Left bound. Anywhere on my calculator on the left-hand side. Enter. So now I'm telling the calculator look for the maximum in here. Push enter again. And there it is. 3.96. Which is what we had, and then we had 1,040, okay, 3.96 and 1,040, okay, so that's how to use a calculator. You can rewind that if you want to. You can pause it and take a look at it, okay. Now, our lesson, though, today was on max-min problems. Oh, I'm sorry, it wasn't. It was on factoring problems. So we looked at problems like this today on 2.6. I saw 4 terms, so I factored by grouping. The first 2 have an x squared in common. So pull out an x squared, x plus 5. Second 2 have a negative 4 in common, so got a negative 4. Both groups then, I factor again, have an x plus 5. Be left with an x squared minus 4. That factors again into x plus 2, x minus 2. I have my mini equations, so I have zeros of negative 5, negative 2, and 2. Okay? Zeros are x values that make the equation equal to 0. Example 3 is a trinomial, so I went 2x squared, x squared. Multiples of negative 3, I went 3 and 1. If I do my double smiley, I need a negative 1x. Positive 2x squared minus 3x squared works. I do my mini equations. 2x minus 3 equals 0. X squared plus 1 equals 0. I solve. Plus 3, divide by 2. Square root, 2 answers plus or minus the square root of 3/2. Or if I rationalize, it's plus or minus square root of 6 over 2. Okay. Second group, minus 1, minus 1. I think I'm going to have a problem because I'm going to take the square root of negative 1, which is I. So plus or minus I. Okay. On the third example, I see 4 terms. I need to be grouping them, but I had to bring over the 6x squared and the 3, okay? Now this grouping was okay, but I thought, what if I regroup? So I regrouped. I put these 2 together, because they kind of go together with 5 and the 10, and I regrouped and put these 2 together. So I can regroup. I put these 2 together, and then these 2 together. So 10x cubed plus 5x makes more sense. Put these together, and then negative 6x squared minus 3, put those together. So then, okay, grouped. What do these 2 have in common? 5x. I'd have a 2x squared minus 1 left over. What do they have in common? A negative 3. I have a 2x squared plus 1. Now, what do they have in common? 2x squared plus 1. And then if I factor that out, I'd have a 5x minus 3. Okay, again, mini equations. Put both equal to 0. Subtract 1. Divide by 2. Take the square root. I'm going to have an I again, because the square root of negative 1. So I have plus minus square root of 1/2 I. Or if I rationalize it, I get plus minus square root of 2 over 2. I because of the negative. And then on the other equation, plus 3 divided by 5. I get 3/5. So I've got 1, 2, 3 answers. Okay. Example 4 First of all, before you look at all the work, I've got two equations. I've got an x cubed, looks something like this, and a straight line, 3x plus 18. Now, they could intersect in three different points. So if I graph them both together, I get my cube and my line. So how do I find these 3 points without graphing them, okay? Well, where they intersect is where they're equal. Where they intersect is where they're equal, so I set them equal. X cubed plus 6x squared equal to 3x plus 18. Then I brought everything over to factor by grouping. Took out an x squared, x plus 6, took out a negative 3, x plus 6. Then I regrouped. What do they have in common? X plus 6, what's left over, and x squared minus 3. And then my mini equations, x plus 6 equals 0. Solving, I get negative 6. X squared minus 3 equals 0. Plus 3, square root plus minus square root of 3. Now, those are just x values. I'm looking for points. 1, 2, 3 points. So I need the y values. So I can plug these three into either equation. So I thought this would be an easier equation to plug it into. Plugged in negative 6, I get 0. Okay, so I got a point at negative 6, 0. I plugged in the square root of 3, okay, into this equation. And I got 23.2, okay. And then I plugged negative square root of 3 into this equation. I got about 12.8, okay. So that's what I have for today. If you have any questions, come see me.